Hello, everyone. Good afternoon, good evening, wherever you are, to our next edition of the Out of the Box Developer Podcast. So I'm very happy to be here with you all. Good evening, everyone. And before we are introducing our guest for today, I would like to say hello to Pedro and Luis first. So, hello, Pedro. How are you doing?
Hey, hello Sheila, hello Luis. Wow, very excited to be here and in one new episode of our beloved podcast. Uh, we love all the topics we have here, but of course, the main topic of the year and the last year is AI, and we we love when we have AI here, and we love when we have like very new stuff about AI. That is
Mhm.
something that is everybody's looking for, and yeah, everybody including us. So yeah, I think you're gonna like it.
hmm Yes, I'm sure. And let's say hello to Louise as well. How are
Hello,
you?
hello, hello, everyone. Yeah, I'm very excited for this topic because, as Pedro said, every day we have something new about AI. So it's not something that we are only talking about the same stuff. We have all new stuff to talk. And I'm very happy because I'm starting a new position as well, and I'll be working with AI for developers. So this topic, yeah, I'm really
Hey,
excited to talk about it.
congratulations.
Yeah, thank you.
Congrats.
Yes, and maybe let's introduce
We
you
have
as well, who has just joined the
yeah.
session.
Here you go.
Hello, you.
Hello, hey everyone.
How
Sorry
are
for
you?
delay. I think just in time, maybe.
Yes.
Thanks all. Thanks. Great to have to be here. And yeah, and not missing this session. I'm looking forward for the topic we're going to discuss. Resilient multi-agent systems. Something uh, it's important to discuss. Okay, not some. It is a very popular solution multi-agent now, and yeah, it's not free food, right?
hmm
So great to be here. Thanks.
Yes. So, first of all, everyone who is here, please write your questions into the chat if you would like to ask any questions during the session, or just say hello that we know who is here today with us in the podcast. And now I think it's time to introduce our guest of the day, Denis. So let's just show him on the stage.
Hello,
Hello, Denise. Good
hello,
evening.
thank you. Hello, all. I really appreciate the invitation. Thanks for having me here. I was looking forward for this conversation.
Mhm. Thank you very much, Denise, for being with us tonight. So, and before we start with the topic of the multi-agent system topic, maybe you can introduce yourself very shortly. What have you been doing so far, and what is your connection with the AI and agentic systems, so that we understand better and we can ask even better questions.
Okay, so I've been working as a software engineer, mainly with Java, only with Java for the last 18, 19 years. Most this is for telecom companies so far. This year is also Java telecom system for
Dennis,
telecom.
I'm not sure if it's only for me, but I can hear very well your voice.
What about now?
I think it's better.
Oh, much better.
Okay. So we work with Java for 19, 18 years, mostly for telecom industry system. That's been my background. And for AI, for the last maybe 2, 3 years, I've been looking to work with AI, learning about AI so far a lot. Yeah.
hmm
Okay. So, okay. So what the discussion today I'd like to bring, like we are living a honeymoon with AI. You can just looks like you just need to know how to write a prompt, a very good prompt engineering, and the AI will do the magic. You just have right prompts, and AI will create a report, chart, send to customer, reply to customer, and you don't need more software engineering. We need more even software engineers. We are done. Just need the right prompts and with a simple Python script, and that's it. Nothing else is necessary. It's like a honeymoon. Everything will be great and no more problems. We'll solve the problems. But then need to remember when we go to production, real life, production real life is chaotic. You may have data table lock, database lattice, third-party API it depends on, might be unavailable, things like that. We all have seen so far with years of experience putting things in production. So that's when you see that that solution you have is actually a house of cards. Need something else to, and if you see some frameworks to have, I've seen most in Python, some frameworks to orchestrate this multi-agent. Sometimes you check documentation, how we handle resilience, fault tolerance. Some of them have simple mechanisms like just a retry, and some will say you need your code to handle that. Yes, it's important. Your code should do that.
And what are the use cases where you are using those agentic systems, or how do you start it, in which environment?
Um, not exactly use case, but mostly for telecom companies. Okay.
Mm-hmm. Okay.
I can give some other examples, okay? And I'll be working. But for example, for now we have using just have using can use AI simple prompts to travel planning agents to process a insurance claim or conventional one, which involve many steps like analyze the application form, risk analysis, market trends, a lot of steps, right? That could be automated. And if you have a multi-agent system and you want your organization to have it all automated with that, you need to be reliable because an organization don't want to stop because of database lattice. The whole organization should not stop because of that. You need to have ideally a graceful degradation. Your organization keeps working. Maybe some features, some values will not be delivered for some time, but the whole organization keeps working. The other parts of the system keep delivering value, right?
Mm-hmm.
So let me share a chart here. So here you can see this wheel here on the sides will be
Just a minute.
are we able to share?
You are
Okay,
sharing.
I have on screen.
I cannot see your screen yet, Denis.
Oh, okay, miss it about
But in the meantime, let's say hello to our audience. Andres is with us again. So hi guys. Yes, we find it also an interesting topic. So hello, Andres. Welcome.
Okay, now I can see Dan's
Mhm.
screen here.
Yes.
Yeah, I missed the button.
Mhm. Yes, I hope everyone can see right now the screen. Okay.
Okay, great. So here on the side you have demo, could be a demo like one agent could be the writer and a review agent. I've seen some demos like that. And works very fine under control with in a demo, in a lab, with all the constraints under control, we can make it to a demo like that. But then we have a real life production reality where you can have latency, API timeout, some AI platform available for a few seconds, and the network is not reliable, and can have some latency. They may depend on third-party API that may change the schema, things like that. So this is the demo, and this is other side is real life. Okay, and just wanna take one step back, just talk about AI agents. If you use LLM, maybe most people know as ChatGPT, right? But LLM is a big neural network trained on very huge text. But using purely LLM is not enough. There are many limitations, like limited memory. You can have some hallucinations. The memory is limited, like it's very limited. If you are using LLM for planning a travel, for example, and you have many interactions in order to get what you want to achieve, and every time you are interacting with an LLM, you need to feed the prompt, feed the conversation you are having, then to ask the next step. So memory of LLM is like a goldfish. So that's when we have AI agents trying to overcome these limitations, right? So the LLM will work like the brain of an AI agent, and we add the other building blocks to create this AI agent. You have the context of the conversation, the interaction we're having to achieve your goal. You may add instructions that define the persona for this AI agent, the rules, the behavior constraints. You may add some tools to access external system, external API or the database. You may add RAG. That's a way to make this LLM to be able to access some private documentation. You may have MCP, a standard way to make the LLM model access the standard protocol to access other tools or other agents using agent to agent also other standard protocol. And have the memory that can set some user preference and other configuration for the LLM, right? Just could be some building blocks to create the AI agent to overcome instead of using pure LLM model. And of course, depending on the problem we are going to solve, may select which building blocks will be necessary. But that's the AI agents. I don't have. Feel free to interrupt and question, comments to add here. Okay.
Are there any questions so far?
Yeah. Oh, I think I want the same. Hello. Hear me? Sorry.
Yes, but you might have some connection problems, Pedro.
Yeah, I saw, I realized it. Just a question here, just to put everybody in the same page here. So this is a anatomy for one agent, right? So this is one guy,
Yes,
and then so like when we talk about multi agent, we are talking about like many of these guys here, right?
right, right, right. Each one should be in order to, so LN has some limited memory, and there is some what you have the hallucination. So it's good in order to prevent hallucination. One of ways of doing that is giving a specific task for the AI agents. We're going to do only this, only risk analysis. That's the only task we are doing. That's one of the
Hmm.
ways to overcome limited memory and prevent hallucinations. Because LLM doesn't know what it's doing, it knows to prevent the next word and send the answer. It's good to recognize patterns, but it really doesn't understand what it's doing. It prevents the next word and generates a response. So yeah, it's one agent who is specialized, very specialized, work on a specific task. That's when you have an AI agent. In order to achieve a complex task, like divide to conquer principle, right? You split a complex task in small subtasks, each subtask will be assigned to a specific AI agent. He will be responsible for that subtask. He take the decisions under that every can take a decision as long as it is inside his responsibility, his assignment task.
Also,
And okay, and we think about resilience. A common analogy we can have is aviation. Aviation is an example for us of resilience. When we build when an engine is designed for aviation, it's not something that's built to never break, to never fail. It's built like when it fails, if it happens, cannot prevent it from happening. There is some limits of preventing it from happening. But if it happens, when it happens, we have redundancy and other engines is enough to keep the plane flying and find a safe place to land. So, and then another redundancy system we have in an airplane. That's an example of resilience. Cannot, there is a limit you can go to prevent failure. You need, in order to be resilient, you need to plan, have a broader goal, how to be resilient. So you need to have more strategies. Just to, let's give some concepts here. Fault tolerance would be you trying to overcome a specific error that might happen. Can be a database latency, can be an API that would be unavailable. That's work on fault tolerance. We're working on a specific error, specific failure that may happen. And resilience would be a broader concept when you work on observability, open telemetry, external configuration, a lot of other things in order to make your system to keep working, although you may have some failure on some place. Right? Give some concepts. So that's a good just comparison when talk about resilience. Example. Also have on ships. We have a bulkhead on ships in order to prevent floods in a ship and for it to sink. So the example of resilience we have in real life. Okay. So give one proposal for that. And we suppose we wanna make your system reliable, add resilience, fault tolerance. We want our software engineers to keep work on solving the business problem. We don't want them to keep work, add some code to prevent fault tolerance, to prevent add some code to work on telemetry data, external configuration. What we want that our software engineers keep solving the business problem and want to use abstractions to to handle fault tolerance, telemetry data, in order to have resilience. So it will be embedded, many are prone to let software engineers work on this to handle this fault tolerance. So I have been using this architecture, event-driven architecture. That's an architecture pattern style we have used it for many years so far, and it's very reliable because this event-driven architecture is composed of independent event processor. We have an event bus where events will be published, and here's these examples from a commerce company. Might have different event processor, one for inventory, another for payment, the third one for shipping. So each one will be independent, loosely coupling, and the inventory microservice, for example, we receive an event for inventory, and to process the events, when it's done, you may publish a new event, the event bus that might be consumed for other processor events. And they are independent. If there is an issue, a failure on any of these event processors, the other event processors can keep working. They all will be processed events asynchronously, and each one can scale independently also. Right? This is the event-driven architecture I have used so far.
So you are basically using similar design patterns or architecture patterns that we used to use in software engineering or traditional architectures. And you are using similar architectures right now for agentic systems, right? But there
Right.
are Of course, differences. Where do you see the differences? Where to pay attention? How can we use those old patterns for this new use cases?
Okay. For this case, we have a challenge on where this because you'll be challenged because it'll be difficult to debug, right? To trace errors. I have a distributed architecture like this. But we are seeing is like multi-agent system is a distributed system. It's a distributed system. Have multi-agent. Each agent may have different tools, MCP, things like that. And so it's a distributed system. So my proposal here is based on event-driven, we can combine event-driven architecture with multi-agent system in order to have a resilient multi-agent system. That's the idea here.
Mm-hmm.
So if we have event-driven architecture with multi-agent system, each agent can work as independent event processor. They don't have direct dependence between each other since they will use events to communicate between each other. So each AI agent or event processor will work independently. Some failures might be handled by the event bus. Okay, since there is there are loss coupling between this event processor and AI agents. So they are fault tolerance, a failure in some tool or increase the latency of one of the agents doesn't affect the other agents. I think they keep working, processing events. That's the idea here. So event-driven architecture can be used to integrate with other systems. Also good just using event bus and the other couplets. Can be used for small, big systems. And since every AI agent be processed in parallel, you can get a high throughput. High concurrence is also a flexible architecture. If you need to add a new AI agent, you just need to add a new event processor, subscribe to the events that might be interested. And so it's a flexible to adapt to the business change.
Mm-hmm.
So, okay, I have a, yes. If there is any comments, I could go to a demo. So that's the demo I'm going to demonstrate today. We have a front end for the event bus. I have a Kafka broker here. So we have a front end web. Then we have three event processors. Here's working as a pipeline. So the first enrichment processor. So this demo will be like in a streaming company. You want to publish a new content to have for your streaming platform as fast as possible, reduce manual effort, and, and prevent error, human error. So we have a front-end web UI when you will be publishing the new content to have for your AI streaming platform. And the first event processor, we have an AI agent that we call it an enrichment processor. Be responsible for extracting of this new content and some keywords for this content. Then we have the second agent, event processor, that will be we call the sensitivity processor. This agent will be responsible for get the age rating for this content for your platform, stream platform, the age rating, and some risk flags your content may have. And then after this event process, the agent is done, you publish the content, and we go to the marketing processor, event processor that will have an AI agent. And the marketing processor will be responsible for generating headlines, taglines, so you can publish the content on social media as fast as possible. That's the idea here. So they'll be working on pipeline, work independently, but in a pipeline. And each agent will see all the metadata that was added by the previous agent, and be adding more metadata on the content that we publish it. And at the end, we have a final stream output. Okay? And we will be able to see this final output in the front end also. So just wanna go deep, show some code here. This demo is using Quarkus, LangChain 4j extension from Quarkus to interact with OpenAI, choosing GPT-4o as LLM model. So here is the code using LangChain for the first AI agent, will be the content enrichment agent. So given the content that we published, the first topic is to extract the narrative theme, emotional tone, audience profile, and advanced keywords. And to return this content, since here we are using LangChain 4j, we have a well-defined contract with this AI agent. So we have a well-defined bean here, so Java record, we are defining bean here. So that will be the inputs, and also another being that will be the output. So it's good, easier to integrate with the system when we have a well-defined contract with it. Right? And then this will be the second agent, where that will be responsible for context sensitivity and compliance, giving all the context that was published and the metadata that was added by the previous agents. This agent will extract the age rating, regional specific restriction we may have for this context, and if there is any risk flags for this context. So adding more metadata to this context, and will generate a sensitivity results. That will be a new event for the next agent. And so this will be the last agent that will be responsible for creating a marketing specialist. Oh, this is the system message, will be the system prompt for the agent. This is the API for LangChain, for J. So give you the context that's all generated by the previous agents. We generate a marketing headline, a punchy tagline, and a promotion description for this content you want to publish. So these are the three agents we have. In order to be fault tolerance and resilience, I'm showing this. This is a configuration. We have an extension in Quarkus. So we have here retry, circuit breaker, and timeout. For every agent has this. So when it's retrieving an event to be from the topic to be processed, so have a retry here for this configuration. Have a retry for max 3. So it's a retry 3. So every event will be processed a maximum of 4 times with a delay of 1 second and a variation of the jitter delay. So if you have many retries, every retry will not happen at exactly seconds, milliseconds. That's the idea of the jitter. And also have a circuit breaker. Oh, if the retry, if we reach the maximum of 4 retries processing events, we have a dead letter queue. So the same event will not be processed, keep being trying to be processed indefinitely. And we also have a circuit breaker. So for any event that might be processed, here we have a window of 4 guest column, so a failure rate of half of them. So now window of 4 events being processed. If half of them failure, like 2, then we're going to stop processing events, which wait a delay of 10 seconds. That's a chance to prevent a cascade of failure in your system. It also gives you a chance for this other system to recover and be ready to process events again. And after these 10 seconds, you select one event, try to process it. If it's successful, you consider the circuit breaker. The circuit is closed again, and you keep processing events. If you fail to process another event, the circuit is recalled open, and you stop the processing event again. Also, there is a timeout of 60 seconds. So again, another an event not be processed here, keep it being processed here indefinitely. So showing this for the first agent, but every agent has this.
Okay. So this is agent.analyze is the actual call to OpenAI. And it's like
Yes,
rapid
yes,
and
that's the call for the agent. Yeah.
all this resiliency uh, abstractions. That's awesome.
Right. Yeah.
Kind of easy, right?
Yes, and here we'll generate the events for the next stage. Getting the odds we have previously, and the new metadata generated just generates an event, which the return will be the event for the next agent. Right here, for this demos work as a pipeline, and we can have other topology, talking multi-agents, if event-driven architectures can be other topology. For this example, it's working as a pipeline. Of course, there is a failure on the last agent. The other agents can keep processing events. My need is just wait for the last agent to be back. Then we'll be able to process all the backlog we had so far, and the whole system will work again. And Kafka to be a reliable platform for long.
Yeah, and
So just
how I saw that in the dead letter queue in your on your architecture, how the dead letter queue is handled here in this situation.
okay. In this situation, when it reaches the maximum tries of 3, so after 4 times trying to process this, it will go to the delay queue. Then we can have some observability to receive a notification if anything goes to the delay queue. And maybe see
Hmm.
pretty so far.
And we can and then we can add like another agent that reads that letter queue from time to time to retry or something like that.
Right, right. Yeah.
Mhm.
Agent or a human to analyze what happened. Yeah.
Oh, yeah, we put a human to do that. Okay.
Human agent.
Human is still useful here.
Oh, you're still agents.
My question here is, I think the Kafka usage there, it is on the first user interaction, the message the user send, or also in the in each step of this enrichment analysis between agents. They are also using Kafka for communication.
Yes.
I got a bit confused here. Yeah.
Okay. Okay. We are using Kafka for all the interactions with the orchestrator to exchange events between these agents. So different topics between each agent, but they are using Kafka. Even the front end, there is a backend on the front end that's consuming. It's publishing. If it starts the pipeline, the backend front end, there is a more backend that first publish the content, the start of the pipeline, and it go each agent and a different Kafka topic, and that there is the last topic where the content is final published, and the backend for the front end will also consume that to show the UI. And
Cool.
Kafka topic has a corresponding dead layer queue if there is any failure.
Mhm. Cool. Cool.
And here I'm using Kafka, but it's not different. We could use some queue technology we have in others very high, very big cloud providers who have similar queue to implement event-driven architecture. Just here an example for them. And there is a span code here. I'm going to show how to track traces and span on Grafana. So for now, feel free to ask anything. So if not, I'm going to the demo. Hope it works. So here's the UI. So suppose you're a streaming platform and you wanna publish new content. You got a new content, you wanna publish that as soon as fast. Let every all the subscribers have to know have a new great content. So I have here I was testing this is the content that was already generated by the platform. You can see here We have the title, description, and we have a headline to publish this, a tagline, short description, emotional tone, audience profile, themes, keywords, age rating, is parental guidance, and no sensitive regions for this content. Let's publish a new one. I got so there's a link to publish a new content. Let's get here an example of skills. So just add here title, description, generally say it's a comedy, and region that's a global contents. I'm going to publish it. It just starts the pipeline. We go through each agent. Each agent may take about 1 2 seconds to generate the metadata and go to the next agent. So it may take about 6 10 seconds to to go through the pipeline. Just wait to result, then you can track the trees. Good. Now have the new content, the office scales. So when a texture type accidentally hires 2 people for the same job, both refuse to quit, and the entire office must pick a side. So it's a comedy, global, and again, the age rating is parental guidance. Here, it's a demo, okay? The sensitive and compliance was really small agents, simple agents, just with a system prompt. I know if you're going to define the age range for a content, may have different rules, depends on the country, European Union, things like that, which you may add to define different prompts, depends on the country you analyze the age rating, different rules depends on the where this content will be available, right? Here's just for the simple demo, it's only use a simple system prompt to define that. Uh-huh. So global headline, tagline, short description, emotional tone, all of these are generated by AI. So the idea is that with this, you'll be able to publish the contents faster.
It just remind me that we need something automated like it for our sessions to, to publish the post and make uh and publish on the LinkedIn to announce it. It's very cool.
Right, right, good, very good. So, okay, this is the front end, and we can also track it here. Here, everything is running here as a I have a Docker here. Each agent running as a Docker. Kafka is running here as a single broker. And also I have Grafana LGTM running here. So this is an example I was testing here before. We can see the trace. The trace will be, we track everything that happens to when it's processed a single context. And when we reach each event processor, we have a span inside it. Each step will be a span. A trace will be composed of many spans. A trace works. So here, when the first content to be published, you can see it's probably, how long it took at this step to publish the content. And after a few microseconds, it reached this, of course, it's running all here locally. So it reached the first agents, the content enrichment. You can see here, GPT-4o when sent the request to Open API platform, it took almost 3 seconds to process that. Then after a few microseconds, to reach the second agent. And again, it's here for the second agent. It took about some seconds to respond. And then we reach the last agent, the market narrative, where you can see again the when send the request to OpenAPI platform, it took almost 2 seconds until the content finalized. So here we are using an event-driven architecture style. It might be complicated to track what's happening inside it when I have to to do some audit to understand why some content was not published right, for some metadata missing or it's taking too long, what's happening. So we need to leverage some tools like that to understand. And some event-driven architecture style offer tools like that, right? Horizontal telemetry, trace. Some have some, since we are using Grafana, have some metrics. There's nothing that's new since this is a Java application running on Quarkus and have some standard JVM metrics, right?
Yeah, but I think it's interesting to say that I think one very powerful tools in the Java ecosystem is exactly these profiling, debugging tools, right? That you can observe and clearly have the track of everything, what's happening behind the scenes for everything. So you have a very good tooling for that. And I was impressed that most of things that you just shared during the agent definition, it's a lot of mostly configurations that you put there. So that's a very good support from, I don't know, I think it's Quarkus notation, some of them. And that will let you put all these working with just a few annotations, and it's impressive how nowadays very quick to have something like that working. And if you think a bit, it's a quite complex architecture that you're talking about, having Kafka streaming working behind each agent. You mentioned that each agent are Docker containers that is running, and they connect to the Kafka streams to send messages, and I really felt like, well, that's lots of things running behind, but it's a few steps of configurations. Sounds really, it's really interesting.
Right, yes. I may not remember exactly the name of the extensions I'm using here, but I have professionally worked so far with Spring, mostly with Spring Boot was. But when I work on personal projects, I mostly use Quarkus to learn. So professionally Spring, and I want to do something fun, I go with Quarkus. I really like the proposal of Quarkus to make better performance for the presentation. So that's why here is using Quarkus. But as LangChain4j makes really easy to integrate. Like we are connected with a database using LangChain4j to work with the external tool like a database. Yeah, just some annotations. Integrate with Kafka Quarkus is really simple. Just some annotations, the topic name, and the events will be the inputs of a method. And the return will be published on the next event on our pipeline. Yeah, Quarkus makes it really easy. Though there is some configuration to make this open telemetry working. But things like that, these are demo, but things like that, it's trace metric, something you can use in production to understand. Sometimes you limit the trace you want to generate traces for all the content, all the events that be published in production, but some of them, more percentage of that may want to have some trace and metrics to be generated to track what's happened. Have some percentile about how long it's taking processing each event processor is taking. Oh, there is another dashboard interesting to share. There's a
One
dashboard.
question.
Hmm.
Okay. Sorry.
The dashboard for LangChain4j. So LangChain4j is an extension from Quarkus that I'm using for this demo. So we can here we have three AI service agents: the content enrichment, the marketing agent, the sensitivity agent. Each one what's the name of the instance it's running. And here we can, yeah, size of it's good. The input token usage. So you can see for each agent, I don't know, it might be small here, but here we have the name of the agent, content enrichment, choosing GPT-4o, and how much input token have been spent with these agents. And for the market narrative, have again the total input token, sensitive and compliance, the another input token, And here the output token has spent. Again, for each agent, you can track it here. Here's Mario's example. You can draw a different panel here from just the total of output and inputs as possible. But how is being tracked here? And LangChain also generated estimated costs for each agent. So each line here, color, belongs to one agent, like the yellow one's the market narrative, the green one is the content enrichment, and the blue one sensitive compliance. Here you can track how much is going the cost of each agent, how much going the cost for each agent. Important to track costs using AI, and like you have here Grafana and Prometheus. Doing that, you can even configure some alerts here to be notified if you go that much you don't want might be worried. You can track some, set some alarms, depends on the value. And here,
That's awesome. That was exactly in my. I would ask this question like in the dashboard before, and it would be like if I was you were expecting my question. So because this is a very one of the most important thing, right? You can just like fire lots of agents and then but we need to keep track of the costs because we know that costs are the worst part of the AI multi-agent systems.
yeah, maybe I forgot to say it before, but when we're making you handling fault tolerance, resilience, also with the security bake, you can also have a fallback. So GPT-4o is unavailable. Okay, you can have a fallback to go to Gemini to keep the process. So the organization, the pipeline doesn't stop. You also have a fallback. Don't have here in this demo, but could also have a fallback. So declare a function there. That would be the fallback. The event failure here is the circuit is open here. There's a failure, reach the threshold. You consider the circuit is open. We are not processing send events more from the event processor because we reach the failure threshold. You can have a fallback, right? And send this event to another agent that might be used in another AI platform.
We Dennis, we have a question here from Build with AK7. What are you guys building? Uh, yeah, maybe a quick review of what we are building here, just to
Okay,
for the same
for
page.
this demo, right?
Yeah.
Okay, so the idea here is we have a streaming platform. We want to publish new content. You have a new content, you want to publish as fast as possible, so your subscriber will know that, or we may get new subscriber because we have a great new content that will be available in your platform. So the idea here, you can create a platform to automate that and to reduce manual work and reduce the risk of the content to be published. So the idea here, you have a pipeline. Get back here. Get back to the light here. So the idea here is we have a pipeline where we're combining multi-agent system with event-driven architecture, not to have an AI agent, multi-agent system reliable. We are using Kafka broker. Between each event processor, we have a different Kafka topic that so at first we publish the new content with some summary, description, and then we to go through the pipeline to 3 AI agents, 3 event processors. First one would be enrichment processor that to extract the theme and some keywords for this content. Then to go to sensitive processor that to extract the age rating, some risk flag for this content. And then we have the marketing processor that generates the headline and a short description might use to publish our content on social media. Might need to publish on LinkedIn. Let's publish that on Instagram, TikTok. Like that. Then we have the final content published that has all the metadata that was generated by all the previous agents and to be seen again in the front end, available in the front end. For each topic, we have a corresponding deadline queue. If any of these events failure to be processed for some reason, might be unexpected format, so the AI agent is unavailable, or some tools it uses. Let's say that for the agent rating, probably I believe you have different rules depends on the region. This content will be available for streaming platform. But here for the demo, this agent a really simple system prompt to define the age rate.
Okay, so each step of this is an agent, except for the front end, right? The enrichment processor, sensitive processor, marketing processor, and the final streaming output.
Yeah, this work as a pipeline.
Great. Great.
So this is the front end for that. Publishing content title, description, genre, and origin where this content will be published. And then after that, the pipe go through the pipeline. When it's done, you have here the catalog. It might have some human review here. Okay, I have another agent to review the content was generated by the previous agent to prevent hallucination, right? And then might be ready for human, just a human check before publishing the content. You have the short description, some tagline, global headline to publish its contents. Make check there is sensitive region to publish sensitive topic for some reason.
All this information was generated by the pipeline, right, Dennis?
Right, right. I have simple system prompts
Great.
on each agent. Pretty simple for this demo. Might be complicated to define like sensitive region and again age rating, but here is just using a simple system prompt to define that.
So if there are any questions, then please write it into the chat so that we can discuss it. And maybe I have one question. It's not that connected to this example, but you were talking about that you are using Quarkus for your personal projects to realize such architectures. And at work, you are using Spring Boot. So my question is, how is the acceptance at your work? So are you working in an environment where you are actually building this kind of architectures at work, or is it basically your personal projects, or how is the acceptance at your work towards agentic
The
system?
work has been really hard, no, really hard so far. So far, really hard. Where Spring Boot are really reliable. Most people rely on Spring Boot and work on and Kubernetes and just have Spring Boots on Kubernetes. It's fine. We know it works and don't wanna change so far in production. So far for my experience I have seen on Spring Boot. I know I saw Mateus here, some previous episodes showing Quarkus. I've seen that, but so far I really like the proposal for Quarkus. But professionally, for telecom companies I'm working, so far I have seen only Spring Boot for what I've seen. Years.
Okay.
And in terms of agents, like in your work, uh, uh, there are some difficulties on choosing the model provider or the model itself. Like, oh, we only work with OpenAI, or we only work with Anthropic, or something like that.
Yes, yes. That was the for me the enterprise choose the model. I don't have too much opinion so far. I choose the model. The enterprise already choose. This is a platform. I have a partnership with this that I'm going to be using. Interesting challenge we have like MCP. One time we have an MCP service that sometimes was unavailable. Was what was being updated and they choose that. Once the HTTP agent, you should use this MCP agent to do this, this, and that. And sometimes the MCP is not available when it's processing a request. And see the results, did they choose that? Hey, you may ask, have you used that? No, it was unavailable. But it was really hard to make the agent really always use the MCP to perform a task. If it's not available, just do it by itself. 3 times to make the agent do that. Do exactly what I'm doing. Pretty hard. I was worried about accomplishing my task instead of doing it exactly the way we want.
Real world challenges, right?
Yeah.
Cool. Cool stuff. Yeah. And at your work, do you use, probably you're using Spring AI then, because it's all over Spring Boot, right?
Yes, yes. Spring AI is also challenging because work you need to choose the latest Spring Boot version. Sometimes that's not the reality. On production, they have some older versions of Spring Boot. It's better to try the LinkedIn 4J because it works for that nice. You can get LinkedIn here. I have LinkedIn 4J work with Quarkus, but Java Experience works fine. LinkedIn 4J with Spring Boot. Get the older version of Spring Boot.
I see. I see. Yeah, cool. Spring LangChain 4J community, I believe that they are doing great work, right? It's standalone. It's a library that you can use in almost every Java application. It's easy to integrate. Cool stuff.
Yes, yes. Coming with many features to do that. Yes. Some people in the community also say that LinkedIn 4J has more features than Spring AI. Depends what you want to do. I'm not that specialist on AI. I've done some things, but not specialist. But some people find more features in LangChain than on Spring AI. Just launched a little later. Right?
Yeah, that can be true because LangChain is older than Spring AI.
Yeah. Well, let me ask you: Do you have any uh, advice for Java developers who want to start creating multi-agent systems, or, or like how did we start it and how they can achieve that the same?
Uh, uh, using AI, like you can have a great idea. Be careful because if you always say your idea is great, be careful for that. I'll say the idea is great. You're doing great with your idea, but need to critique that what's saying. But you can have great idea, interaction with AI, like generate the demo, and we have here I use Cloud Code to generate this demo, right? And it's really nice. Like for the use a Cloud to generate this demo because like a tool like Cloud is really great to generate greenfield projects like this one. It's really great. It's great. To start with AI, LinkedIn for can look. I personally find easier LinkedIn for J, but I have some demos. My GitHub uses Spring AI. I find easier LinkedIn for J, but it's a personal opinion. Personal opinion. Okay. But find easier with LangChain 4J, find more annotation, simple annotation. My feeling is like Spring AI, I have to do a little more code in that to format the output, things like that. And there's a lot of demo. All the tools we have like Cloud Codes already know how to code that. It's not challenging. Like Cloud, ChatGPT already know how to code that. It's not challenging. They already updated with that. They know how to generate the codes and do it to architect and instruct what you want. But to give some ideas how complex you want, interact with this tool, ChatGPT, Copilot, Gemini. It's also great to generate that.
There is one more comment from
It's
it's
Fernando.
yes, yes. Turned late. Great discussion. I will watch the recap later. Yes,
Great thing.
it's
Yeah,
always.
you're not alone. I also joined late. Sorry for that, guys. Been working and got busy, but I was able to get the end. And I will also watch the recap of the beginning, Fernando. So we will do that together. From what I could see so far, it's a great content. Really powerful what Denis has showed us on today.
Mhm.
Thank you.
Yes, sure.
And this code is do you have that in your GitHub? Did you can you
Yes,
share it?
yes, yes. If you can share, share. I think you already have the link.
We
Yeah, I see
already
the
shared.
link on the chat.
Okay.
Yeah.
It's in the chat.
Link, yes.
Oh, it's here. Yeah, it's
Yeah.
the first sharing here. All right,
Yeah.
cool.
I have that open here already.
Yes.
I didn't see it. I should have done the same.
So if you're watching us, we have the links to Denis' article and his code in your chat. And maybe we can add it in the description after the live session.
Yeah.
Thank you.
So Hugo, does Q have any question? Hey Q.
This is first live.
Yeah,
First
I
time.
think you have questions, but I can't understand him yet. So it will be on the next. We'll let in the next. So yeah, I think that was great to have, especially because you bring a demo here and showcase how it works with the coding example. I think that was amazing. So we can also see, I could also see how easy it is today to make not just the agent but also integration with the streaming platform like Kafka, and having all the resilience enabled for those applications. I think we Java ecosystem inherited a lot from the microservices ecosystem. So and yeah, it's indeed it haven't changed. Even though we are talking about agents, there are still a lot of challenges on the integration part, and yeah, I think that's cool to showcase. That's not a long step. You can achieve it with some frameworks like Spring Boot and Quarkus, easier way, and that's it.
Hey, thank you guys. I just want to say the big milestones for me for being here. I really like the topics you bring here on this channel. I have been watching, and we'll keep watching the next videos over there.
Great.
Mhm.
Thanks a lot for
Thank you.
bringing this content here, for joining us today, Dennis. It was great to have you here with us.
Thank you.
Thank you
Excellent.
very much, Dennis. Any last words? Anyone? No, then.
I already told mine. So-
Yes, yes. So thank you very much, Dennis, for sharing your experience and the example with us. So it's always great to learn more about these topics from someone who has tried it out. So it's a uh, real world experience. So again, thanks very much, and until next time. So
Take care. See you next time,
yeah,
guys.
see you
Don't
next
forget
time.
to subscribe and like and share our
Yeah.
live session.
Yeah.
Mhm.
Thank you. See you.
Thank
Take
you.
care.
See you,
Bye bye.
everybody.
Thank you.